Now let us see the procedure to obtain A inverse using row transformations. Now in the first step we write A into A inverse is equal to I, where we know that I is the identity matrix of the same order as A. In the second step we apply the row transformations on the matrix A, okay, which is nothing but what is called as the prefactor on left hand side, and we apply the same transformations on I, which is on the right hand side. Alright, and the aim of these transformations is to transform the matrix A into the identity matrix. That is, by changing the rows of the matrix A, we somehow convert it into the identity matrix I. Now in the third step we have to remember that A needs to be transformed into I by achieving the required elements in a column wise manner. That means if we are doing row transformations, then we have to achieve the column wise elements. Okay, this is a very important point. Okay, that means we have to first bring first column as 1 0 0, then the next column, and then the next column. So the next line is that within each column, so that means within each column of the transformed matrix A, we have to bring the element 1 first, and only then we have to adjust the remaining elements, which are the zeros. Alright, so once we do the sums it will be clear, but this is the sequence that we have to follow in every sum. Okay, even if there is slight change in maintaining this sequence, the problem might occur. So therefore it is very important to stick to this particular sequence. And at the end what happens is, as a result of this process, since RHS is also changing, that is on the right hand side whatever I also undergoes the same transformations. So at the end of the process the right hand side will have got converted into a new different matrix, which will be nothing but the inverse of the original matrix. Alright, so let us see once again how this procedure works. So to start with, we have A into A inverse equal to I. Now, as we have seen, we have to convert this particular matrix A into the identity matrix I, correct, multiplied by A inverse as it is. Now by that time A gets converted to I, the I which is on the right hand side will also get converted into some matrix, say B. Right, now on the left hand side, when any matrix is multiplied with I, the result is nothing but the same matrix. So I into A inverse is nothing but the A inverse, that is equal to B. So that is what we saw, that is whatever matrix gets formed on the right hand side at the end of the entire transformation process, that is nothing but the inverse of the original matrix. Alright, so now let us go ahead and take one concrete example so that this entire process will be clear. Now here we have to find the inverse of this particular matrix by elementary row transformations. Now it's assumed that the matrix is a non-singular matrix, that is, we are not going to show that it is a non-singular matrix. So we will move ahead with the actual process of finding the inverse, because if you remember, if the matrix is non-singular, then the inverse will not exist. Right, so as a step 1 we write A multiplied by A inverse is equal to I. So therefore putting the values, we have A is nothing but the given matrix, that is 2 0 minus 1, then 5 1 0 0 1 3, multiplied by A inverse we'll write as it is, because that is what we want to find out. And on the right hand side we have to write the identity matrix of the same order. So since we have 3 by 3 matrix, we write the 3 by 3 identity matrix on right hand side, which is nothing but all the diagonals as 1 and all other elements as 0. Alright, now if you remember, the next step is that we have to somehow convert the matrix on left hand side into an identity matrix. That means somehow we have to achieve 1 0 0 0 1 0 and 0 0 1 on the left hand side matrix, and the process or the sequence to achieve that is column wise. So that means first of all we must concentrate on achieving the first column as 1 0 0 from the existing column. So this is our first aim. Now after that we try to achieve the second column, that is 0 1 0, and then at the end we achieve the last column. Alright, so now with that in mind, let us now proceed to find out how we can do this particular transformation. Alright, now if you observe closely the numbers 2 and 5 in the first column, we can sense that if we subtract twice of 2, which is 4, from the 5, then the answer will be 1, and that is what we want in the first column. Right? So therefore let us apply the transformation that row 2 has been changed to row 2 minus twice of row 1. Right? So this will give us, see, the first row is not going to change, so that will remain unchanged as it is. From the second row we have to subtract twice of element in first row. So 5 minus twice of 2, that is 5 minus 4 is 1. Alright, so that I write as 1 here. Then 1 minus twice of 0, which is 1 minus 0, that gives us 1. And then we have 0 minus twice of minus 1, that is 0 minus minus 2, that will give us plus 2. Alright, so second row has been changed. Third row remains intact. A inverse is equal to, now on the right hand side the first row will not change and the second row will undergo exactly same transformation that we did on left hand side. So 0 minus twice of 1, that is 0 minus 2, gives us minus 2. Now if you look at the other pairs, you know, the first row has the two elements as 0, so therefore effectively no change will happen to the elements in the second row. So the remaining two elements remain as they are, that is 1 and 0, and lastly the third row is once again unchanged. Alright, so now here if we look at first column, we have obtained 1, but it is not at its right place, that is it should be present in the first row. So therefore to do that we simply interchange row 1 and row 2. Alright, so this is how we are using the row transformations. So after exchanging row 1 and row 2, the first row will become 1 1 2, the second row will become 2 0 minus 1, and the third row remains intact, 0 1 3 into A inverse is equal to, now on the right hand side also we have to exchange row 1 and row 2. So the first row now becomes minus 2 1 0, second row becomes 1 0 0, and the last row is 0 0 1. Alright, now if we once again look at first column, we have got 1 in the correct place, we have got 0 in the correct place. It's only the second element 2 that we have to change with, rather change to 0. Now the reason that we try to bring the element 1 first in the column is that with the help of that one we can change the remaining elements to 0. So we have to take the help of this particular one to transform the 2 to 0, and it is not difficult to see that if from the second row if we subtract the twice of first row, then we will get 0 in place of 2. So therefore we proceed with that particular transformation, which is nothing but R2 change to R2 minus 2R1. Alright, so therefore we get, the first row will of course remain the same, there is no change to first row, so that remains as 1 1 2. Now from the second row 2 minus 2, that gives us 0. Then next we have 0 minus 2, that is minus 2, and we have minus 1 minus 4, which gives us minus 5, right? That's the second row. The third row remains unchanged, multiplied by A inverse is equal to, on the right hand side, first row is unchanged, so we write it as it is. Okay, second row is changing to second row minus twice of first, so that is 1 minus minus 4, that gives us 5. Then 0 minus 2, that will give us minus 2. And lastly we have 0 minus 0, which is same as 0. And here also the third row remains unchanged, so we write as it is. Now if we look at the first column, we have obtained the required column as it is. Now we turn our attention to the second column. That means we have to achieve 0, 1, 0 in the second column, right? So now if we look at the elements of second column, whatever we have got at this stage, we already have this 1 in the third row. So only if we just interchange second and third row, the 1 will go to its correct place, isn't it? So without doing any further complicated transformations, just by mere exchange of rows, we can achieve 1 in its correct place. So therefore let us do that particular transformation, which is nothing but R2 interchange with R3, right? So as a result of this we get 1, 1, 2, then we have 0, 1, 3, and then 0, minus 2, minus 5. So these are the interchanged rows, multiplied by A inverse is equal to, now here also we have to do the same transformation. First row remains unchanged, that is minus 2, 1, 0. Now the second row will be 0, 0, 1, and the third row will be 5, minus 2, and 0. Alright. Okay, so now basically we have achieved 1 in its correct place. Now to transform the 1 in first row, we have to merely subtract second row from the first row, and similarly to transform this minus 2 to 0, we have to add the twice of second row to the third row. So therefore now we can change row 1 and row 3 in a single step with the help of the second row, which is not going to change. So therefore if we are changing two rows in terms of a third independent row, then those changes can be done in single step only, so that we don't have to do that one after the other. So here as we saw, first row is to be changed to first row, that is R1, minus the second row, that is R2. And the last row is to be changed, that is R3 is to be changed as, now if we see to the R3, we have to add the twice of multiple, the second multiple of second row, so that is 2 times R2 we have to add to the third row, so which will result in the desired elements in the third row. Alright, so that is how we apply the transformation of third row. So as a result of this, what we will get is, so the first row is 1, then 1 minus 1 is 0, and 2 minus 3 is equal to minus 1. Then second row is unchanged, that is 0, 1 and 3. Okay, in the last row if we see, the 0 will remain unchanged, then minus 2 plus 2 gives us 0 as required, and minus 5 plus 2 times 3, that is minus 5 plus 6 is nothing but 1, so therefore we get 1 there. And coincidentally, if we think of the third column, we already have 1 automatically adjusted at its correct place, so that's a good thing. And multiplied with A inverse gives us on the right hand side. Now on right hand side, the first row will change to, we have to do the subtraction, that is minus 2 minus 0 is nothing but minus 2 only. Then 1 minus 0 is nothing but 1, and 0 minus 1 is nothing but minus 1. So that will become the first row. Second row is unchanged, so that remains as 0, 0 and 1. And in the third row we have to add the twice of second row, so that means 5 plus 2 times 0 is 5, minus 2 plus 2 times 0 is minus 2 only. Yeah, and lastly 0 plus 2 times 1, so that gives us 2. Right. So this is how we transform the right hand side. Alright. So now with this we have also achieved the required elements in second column. So now the second column and first column are ready. Alright. So it's just the last column now that we have to adjust. Alright. Now if you observe in the last column also, the element in last row we already have got 1. Now to change the first row, we have to simply add third row to the first row, so that minus 1 plus 1 will give us 0. And to transform the 3 to 0, we have to subtract 3 times third row from the second row, so that 3 will change to 0. So that means here also we can do the two operations in one step to get the answer. So that is the first step, is that we have to change R1, I will write here, by adding R1 with R3, that is to first row we add the third row. Right. And how do we change second row? That is, to the second row, the operation that we do is from the second row we subtract 3 times the third row. That is, from R2 we do R2 minus 3 times R3. Times R3. Alright. So as a result of this, we can see that this will get converted into the identity matrix. So that multiplied by A inverse is nothing but going to be A inverse. Now on right hand side we have to apply the transformations and get the final answer. Alright. So let us do the transformation on first row. That is, to the first row we have to add the third row. So that is minus 2 plus 5, which will give us 3. Then 1 minus 2, that is going to give us minus 1. So that is the second element. And lastly we have minus 1 plus 2, which is nothing but plus 1. So that is our first row in the final answer. Okay. Now in the second row, from the second row we have to subtract 3 times the third row. So that is 0 minus 3 times 5. So that is nothing but minus 15. So that we write as the first element in second row. Right, minus 15. Then 0 minus minus 6, which in turn gives us plus 6. And lastly 1 minus 2 times 3, that is 1 minus 6 is nothing but minus 5. So therefore that is the last element in second row, minus 5. And the third row is unchanged, so therefore there is no change in the third row. So therefore we have 5 then minus 2 and 2. So 5 minus 2 and 2 are the elements in the last row. So this is how we get the inverse of the required matrix with the help of elementary row transformations. So just to recap, what we do in this particular sum is that we started off with the statement that A into A inverse is equal to I. Alright. Then we wrote the value of A as well as we wrote the value of identity matrix on right hand side. Now the idea was to convert the A on left hand side into the corresponding identity matrix with the help of row transformations. And what do we do to achieve that is nothing but we achieve the desired elements, that is ones and zeros, in column wise manner. So therefore we first tried to change only first column and attained 1 0 0. Okay, and after that we obtained the second column as 0 1 0, and at the end we obtained the last column as 0 0 1. So by this time whatever change occurs to the right hand side, that will get transformed into the inverse of the given matrix.